Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Excuse me. Now my voice will sound a bit different. The reason being that I'm having a bit of cold and flu. So trying my best to do the second session of P3 for the upcoming exam, which is tomorrow. So we had a session on Friday and today is Sunday. Tomorrow is your paper. On Friday, we focused on these topics, bit of algebra, logs, and trig also, differentiation, integration, differential equation from the papers May, June 2024, variant 32, variant 33, and we did one whole paper that was May, June 2024, variant 31. Got the idea? So that is what we practiced and discussed last time. So let me just get my things correct. Just checking the voices, everything is okay. So now let's focus on the rest of the topics, which is vectors, complex numbers, and numerical solution. And we will start with May, June 2024, variant 32. So this is May, June 2023, my bad. That is not 2024, that is 23. So 24 is already uploaded. So that's not an issue. So May, June 2023, variant 32, variant 33, and this is also 2023. And as far as the other papers are concerned, all the papers of 2024, whether it's February, March, whether it's May, June, whether it's October, November, that's all uploaded. Even the 2025 February, March paper, that is also uploaded. So now let's focus on this one. So over here, question number 3, that is complex number. It says on an Argand diagram, sketch the locus of points representing complex number Z satisfying such and such. So when we draw an Argand diagram, whatever is the case, make sure that the standard has to be fulfilled. Z minus A plus BI, the whole thing modulus equals to R, that is a circle. So minus has to be taken common. What's left on the inside, the real part, imaginary part, the x-axis, the y-axis, that is the center. And this constant over here is this thing. So it's a sketch. It's not a shading thing. So just draw it realistically. Since this thing is 2 units, this thing is 3 units, this thing is 2 units, and the radius is 2. So make sure touch the circle on the circumference. That is the first thing for 2 marks. The next thing, find the least value of modulus of Z for points on this locus. Give your answer in an exact form. That means third form. Well, the exact form is fractions. It's in terms of pi. It is thirds. It could be in terms of E. It could be in terms of ln. Over here, right now, the third form is applicable. Least value of modulus of Z or greatest value of modulus of Z, that means from a point to this loci. So since nothing is written, basically this is Z minus 0 plus 0. So this is distance from origin to the locus. So the only thing that we know is the center and this origin. Find this distance. If I subtract the radius, I'll get this thing OQ. And if I have OC and if I add the radius, I'll get the greatest distance. And we have studied both of them in class. So OC, that is root 13. Subtract the radius, that is the least value. And let me just write over here in some case, maybe tomorrow, if they ask for the greatest value of modulus of Z, so that would be root 13 plus the radius, which is 2, and then just write units over here. So this is again, like last time, I labeled some questions which are my favorite. So let me label this question. So this is a favorite question. This is about complex. This is about loci. This is greatest least value from point to a circle. From point to a circle, they can ask for greatest least value. If they ask for point to a line, they can only ask for the least distance because that will always be the perpendicular distance. They cannot ask for the greatest distance because that would be infinite. So now this thing is done. Question number 5, another complex number. And now this is algebra. Just have a good look at it. So now it says the complex number 2 plus yi. Now these kind of questions do cause trouble because first of all, they don't look friendly. That is the first thing. Secondly, some kind of simplification is there, something very strange kind of feeling you get, something challenging. So if you come across such a question, if you want to skip it till the last, you're most welcome to do it. So now it says the complex number 2 plus yi is denoted by a. Now make a habit of underlining. Of course, I have this option of all this colored thing over here. And definitely you don't have that option in the paper. So I think the best option is that we should play safe and underline with a pencil. So always underline with a pencil. So over here, this 2 plus yi, this is a. Keep that in mind. So a is 2 plus yi. Now it says where y is a real number and y is negative. It is given that f of a is this thing. A cubic equation is given. Function is given. Find a simplified expression for f of a in terms of y. So very simple. Just plug in wherever there is a, write 2 plus yi. Now, it's my personal preference. I believe in taking common. That means between these two terms, let me take a squared common. I haven't taken common throughout. I just took common from these two. Someone can take common throughout also. That's their choice. I wrote a square, a minus 1. This is 2 plus yi whole square, a minus 1, 2 plus yi minus 1, minus 2a minus 2 into this. And then look at all the simplification. Look at all the algebra, all the messy things. There is a plus sign in between. Take care of negative positive sign. Take care of I square is negative 1. And you are getting a term with y square only and a term with I in it. So the y square only, that is the real part. The I term, that is the imaginary part. Whatever are the coefficients, that should be inside a bracket. And then it says, given that real part of f of a is negative 20. So this real part is negative 20. Negative, negative cancel. Y square is 4. Y is negative 2. Y is positive 2. It says that y is negative. So that is why we are discarding this. We are taking this. Now, they are asking for argument of a. So a lot of people, what they do is that they plug in the value of a over here or something like that. We don't have to. A is already given. So y is denoted as 2 minus 2i. X is positive. Y is negative. That is the fourth quadrant. The basic angle is 45 degrees. Tan inverse of 2 over 2. Always calculate with the positive ratio. It's in the fourth quadrant. Therefore, theta is negative alpha. Because in complex number, if in the first quadrant theta is alpha, over here theta is negative alpha. Over here in the first quadrant, if theta is pi minus alpha, so over here theta in complex number, that would be alpha minus pi. It's direct opposite of that. Just keep that in mind. And that's how you get this answer. What I can do is that let me first get over all the complex numbers thing. So let me just go over here. And I'm not interested in this. So now this one over here, that is 2023. Let me go over the complex first. So I want to get over with complex first. Now this one, nice question. Just read the question. Look at my working. So now over here, it says on a sketch of an Argand diagram, what do we have? Shade, the region whose points, shade, it says shading. Shade the region whose points represent complex number z satisfying both inequalities. So now we are looking for a common region. Which region are we looking for? First of all, take the minus common out. This is the center. This is the radius inside the circle and including the circumference because this is solid line. So solid line, that is inclusive. Dotted line is exclusive. Z is greater than z minus 4i, z minus 0 plus 0i, z minus 0 plus 4i, perpendicular bisector of the line joining these 2 points. So one point is 0, 4, the other point is 0, 0. Therefore, the perpendicular bisector is this thing, which is y is equals to 2. That is common sense. You can also do the calculation if you want to. It's closer to b. Just focus on the lesser side. It's closer to b. So 0 plus 4, that is this thing. So that is the perpendicular bisector. It is closer to this point. That means it should be above the line and it should be inside the circle. So that is the basic thing that you need to draw. This is for 4 mark and this is just one part. Now let me scroll through it if there is any other complex number thing. Again, I'm just focusing on complex numbers. Sometimes people join in late and they are kind of clueless. So let me do the narration. So it's my determination that even with a fever, explaining everything to you people, I hope you people benefit from whatever the lectures that I upload. And inshallah, you will be doing great tomorrow. So now over here, question number 11, another complex number thing. The complex number z is defined by 5a minus 3i, 3 plus ai. Now, a lot of people, when they see a question like this, let me just show you one thing. This is February, March, variant 32. And there was a question over here of complex number. I'm just looking at that, in which I would like you to go over that. Yeah, over here. Over here, this looks like this, right? This looks like this, but there is a difference. This is a constant. There is an I term. This is real. This is imaginary. Over here, this is z. Z is still x plus y, iy. So therefore, that is x plus iy plus 3i. Therefore, this is the imaginary part. That means if you are interested in rationalizing, you have to multiply and divide by conjugate of denominator. Now, in this particular question, which year it is? October, November 2024, variant 33. I did it by cross multiplication. Do watch this thing. That will be beneficial for you. So now over here, find the value of a, and argument of z is negative pi by 4. A is an integer. And first of all, what we need to do is that we need to rationalize this. Just hold for a second. Let me get some water. So now over here, it says 5a minus 2i over 3 plus ai. Now, this is a complex number. There is no hidden I in it. So you multiply and divide by 3 minus ai, 3 minus ai. You know the rationalization part. That is the real. That is the imaginary. Let's work with basic angle. So tangent of pi by 4 is 1. Therefore, the imaginary over the real, of course, this will cancel out. So you have to be very sharp. You have to be very sharp. Don't write unnecessary thing. At the same time, write all the essential thing. So therefore, 5a squared over 6 divided by 3a is 1. Now, someone can ask this question, sir, they have given us pi by 4 negative. So why are not taking the minus sign into consideration? Now, I believe in simplification. Simplification is the name of the game. What I believe in that, the basic angle, no one is arguing that it would be this thing. This negative sign simply shows that it's in the fourth quadrant. So let me just work with the positive ratio. And when I'll have the values, I'll plug in and this will reconfirm that my choice is correct. Cross multiply, middle term factorization. A is positive 2, A is 3/5. It says A is an integer. So accept, reject, plug it in over here. This is 2 minus 2i. A beautiful coincidence. This is the same complex number as it was in the previous question, previous paper. So that is how this question number 11 is done and dusted. So now this thing is done. This is 2023 variant 33. Again, we are focusing on complex number vectors, and numerical solution. I'll be focusing on these three things. Why am I seeing this thing? Okay, I think I've done this thing, this next paper. October, November 2023, variant 21. So another complex number thing. It says on an Argand diagram, shade the region whose points represent complex number z satisfying the inequalities such and such. Again, it's a perpendicular bisector and there are two half lines. So one perpendicular bisector and two half lines. So that is what you're going to do. Make sure you have the minus common out. There is 0 and 2. That's minus 2 and 1. Now, this one is not obvious, so you cannot just write the equation by observation. You have to do the working. There is A, there is B, there is the midpoint, there is the gradient, there is the negative reciprocal. use the negative reciprocal. Let me highlight it. Use the negative reciprocal and use the midpoint. So that is the negative reciprocal. This is x minus minus 1 becomes x plus 1, y minus 3 over 2, put a bracket, and this is the equation that you're getting. So we just need a realistic equation. So over here, it has a negative gradient. The blue is this thing, and it has a negative y-intercept. So that is how I have drawn it. Now this one, argument z minus. So this is the starting point. It's not stationary point, it's starting point. The two angles are 0 and pi by 4. So 0 is along the x-axis because the angle is measured along the x-axis. And this is 45 degrees, just a realistic diagram. So now what is it? It's between, it's closer to a lesser sign, closer to 0, 2. Where is 0, 2? So there is minus 2, 1 and 0, 2. This is minus 2, 1. This is 0, 2. So therefore, it's on this side of the line. So it should be above this line. That is how you determine. And in between the two half lines, so it's an open region. It's like this. So now this thing is done. Hold for a second. Another complex number thing. So now you see the new trend. That is, they have two questions of complex number. Usually, there is no hard and fast rule. And when you have two questions of complex number, so now what you do is that there is one with algebra and trig. There is one with loci. So that's how they break it up. Now, the complex number u is defined by such and such, where a is real. Express u in the Cartesian form, where x and y are in terms of a. A is a constant. A is a real. Of course, it's a constant. It's not a variable. Multiply and divide by a plus 5y, a plus 5y. Simplify. You have this thing. You have this thing. Now it says, given that argument of u is pi by 4, that means it's in the first quadrant. So change in y over change in x, tan inverse of that, tangent of this angle is the gradient, that is change in y over change in x. Just do this. So therefore, 15 plus 2a over 3a minus 10 is equals to 1. Therefore, a comes out to be 25. And what else are they asking? They are asking the value of a. So now this thing is also done. Let me just double check. Is there any other complex number? I don't think so. There will be any other. Okay. So now let me go back all the way to the top, to the second paper. And now let me focus on vectors. So let me do a few questions of each so that till my voice permits, I'll inshallah ta'ala explain it to you. So this is May, June 2023, variant 32. Now let me focus on vectors. We will also focus on numerical solution. That is differential. We did a lot last time. Those who have not yet watched the video, I would advise you to please go ahead and do it. Now, this is question number 11. Just have a good look. Let me first show you the whole question. How many marks is it with? Someone wishing me get well soon. Jazakallah. Jazakallah. Really appreciate it. Now it says the points A and B have this thing, which is over here, have position vectors such and such respectively. The line has equation such and such. So I have a habit of assigning symbols. L is this line. Show that L, and it also says there, my bad. It also says there, L is this thing. Show that L does not intersect the line passing through A and B. What does it mean? It means skew lines. So we have OA, we have OB, we have AB. Now, some people, when they study too much, what happens? Let me tell you something. When you study too much, purple marker, when you study too much, you kind of miss on the basics. So that is the problem. And what is the solution? According to me, the solution is this thing. Stop studying. That means you have reached your saturation level. So that saturation level is reached, and that is very, very harmful for your exam results. So you have reached your saturation point. Now, even the easy thing will feel difficult to you. Now, why am I saying that? Because someone just messaged me, I think in the evening, sir, when we are finding the equation of a line, which point should we take as the fixed point? Now, first of all, the line is passing through A and B. So A could be the fixed point, B could be the fixed point, AB could be the direction vector, BA could be the direction vector. Doesn't make a difference. Double of AB could also be the direction vector. No one is stopping you. But of course, we will believe and work with the simplified thing. Choose the one that looks easier. That's personally your choice. So in maths, yes, there are very few choices. This is one of them. So now I find the equation. I used OA as my fixed point, lambda AB. Line AB, I expanded it. I expanded it in terms of, this is AB, I expanded it in terms of lambda. They have expanded in terms of mu. Another common sense thing. For example, if they would have used lambda, I would have used mu, and vice versa. If they would have used S, I would use T, something like that. So now this is line AB, the X coordinate, Y coordinate, Z coordinate, and equate it to the X coordinate of line L. So the pink with the pink, the purple with the purple, solve it simultaneously. The pink with the pink, you get lambda in terms of mu. You plug it in the purple, you get mu as 1, lambda as 2. Nice numbers. Not always. That's not always the case. Now check in the third equation. So lambda and mu does not satisfy all three equations, therefore skew. If it satisfies, it would be intersect. The two lines intersect, and then you can place lambda where it belongs or mu where it belongs to find point of intersection. But in this case, it is what? It is skew. Someone can also ask this question: what if someone solved the blue and the purple equation first and then plugged in pink? Doesn't make a difference. The values will come out to be different, but over here, it won't satisfy all three equations. So that is for how many? 5 marks. Very simple question. Now this one, again, one of my favorite, and I just have a feel that you people might get lucky and this might come in your paper. So let me just choose this thing. Okay, let me remove this, let me remove this, let me remove this. Okay, so now this is my favorite. Let me write it over here. That is perpendicular distance from point to a line. It's a 5-step easy method. When you look at the mark scheme, there are different crazy ways of doing it. I just explained it in one single way, the 5-step method. So now, what are the method? The first thing is, that is very basic. That is, it says position vector of the foot of the perpendicular from A to L. So perpendicular distance thing, if I find the foot of the perpendicular, I find this distance, the magnitude, that would be the perpendicular distance. So now over here, from A to L, so this is A, you need the coordinate over here. This is L, the equation that was given to us. So this is step number 1. So let me write in white color. This is step number 1. That is writing OQ in the expanded form. OQ in terms of lambda, mu actually. This is for 4 mark. Step number 2. That is over here. Let me write step 2. That is finding AQ. You can find AQ, you can find QA, doesn't make a difference. Step 3. That is AQ is perpendicular to the line. So therefore, AQ, direction vector with the line, should equal to 0. So therefore, this into this, this into this, this into this equals to 0. You find value of mu, which is -1. Step 4. So step 4, that is plug mu in where OQ. Because we are looking for foot of perpendicular, that is OQ. So they can either ask for the position vector, they can ask for the coordinate. That is how you work. What are they asking for? Position vector. So you plug it in and you get this thing. Now let me add 5, because step 5 is what is about the distance. Step 5, the distance between A and Q. There are 2 options. Option 1, let me write it in blue color. So this is option 1. That is, we have -1, 2, -1. That is OQ. OQ, or the coordinate of Q, -1, 2, -1. That is -1, 2, -1. Perfect. And what is A? A is 1, 2, -2. A is 1, 2, and -2. Therefore, AQ modulus, that is be -1, -1, that is -2 whole square. 2 minus 2 is 0 square. -1 minus -2 -1 plus 2, which is 1 square under root. This comes out to be √5 units. And what do you think? This is extra in the sense for this particular question. But this is not extra for this particular question. And over here, what is option 2? Option 2 is plug mu in AQ. What is AQ? 2 mu minus 3 mu minus 3. So this is 2 mu minus 3 mu minus 3. And the third one is what? 3 plus 4 into -1. 3 plus 4 mu. Hold for a second. This is 3 plus 4 mu. And what is the value of mu? The value of mu is -1. So over here, this is -1, this is -1, this is -1, the whole thing like this. So therefore, this comes out to be -2. This is coming out to be 0. And -4 plus 3 is -1. That is AQ. And magnitude of AQ, that is -2 square and 0 square and 1 square under root -1 square. Doesn't make a difference. That comes out to be √5 units. Exact the same answer as this thing. So that is how this thing is done. Third one, let's focus on vectors again. Okay. There it is. Read the question first. Now, this is something with a constant kind of thing, correct? So let me just grab this thing and make it easy for myself for a second. Okay. So now over here, it says there is a line L. So L is this blue line, that is L. And this is the expanded form, is not here yet. And this is M, that is over here. L is in terms of lambda, M is in terms of mu, and the constant that they're using is A and B. There is a C also. There are 3 unknown constants. Relative to origin or the position vector of the point P is such and such. Now, first thing first, let me just focus on one thing. That is this thing. When you read a question, and this part that you are reading, that applies to the whole paper. So this thing applies to everything. So this applies to all the parts, because that is the first paragraph that we have written. So now, part to part, the value of A and B might change. They might continue. That you have to read. Now, first thing first, it says L is perpendicular to M. That means direction vector of L, direction vector of M. The dot product should be 0. So I got this value. That is the value of C. So that was very easy because C was the only unknown out of these 6. Then it says P lies on L. That means in place of R, write down P, which is 4, 7, and -2. 4, 7, -2. Let me just pull this up. It has slid down like this. And then this is equal to, expand this thing, which is 1 plus 3 mu, 1 plus 2 mu. My bad. This is A plus 6 lambda. And lambda is actually, lambda is unknown. C is over here. So C is over here. And this is 3 plus lambda into -2, B plus lambda into -4. So now 3 equations. From the first one, I'll find A. From the second one, I'll find B. So in one shot, we found, and the third one, I'll find lambda. So we have found what? Find the values of the constant A, B, and C, and Lambda came out for free. So something like this. How many marks? 4 marks. Very basic. 4 marks, 4 points. Now this time, let's read this question. It says the perpendicular from P meets the line M. So now it's talking about line M. That is the expanded form. That is step number 1. That is OQ. If they have used the alphabet P, so you should use Q. Of course, never the same one. The point R lies on PQ extended. So we want to increase the length of PQ. With PQ is to QR is 2 is to 3, find the position vector of R. So it's a beautiful question. And again, let me write over here. This again is one of my favorite question, except especially the last part. So therefore over here, this thing, the ratio thing. So basically it's first finding foot of perpendicular and then the ratio thing. And I'll just explain to you how to do that ratio thing. So now over here, it says this is OQ. Step 2, find PQ. Step 3, PQ is perpendicular to direction vector. Find mu. Find OQ. Find PQ also. That's your choice. So I can find OQ. I can find PQ. Now, this is the last thing. It says PQ is to QR. So PQ is to QR. Let's say this is P, this is Q, and this is R. So PQ is to QR is 2 is to 3. Therefore, I can say PQ is to PR is 2/5. Maybe I have done this. Or actually, I just cross multiplied. Okay, that is also good. 3 times PQ is 2 times QR. Not bad. So 3 times PQ is 2 times QR. That's OR minus OQ. I comfortably made OR the subject. I have PQ and I have OQ. I need both of them. Simplify, I get OR. All good. Now this is vectors. Okay, let me go to that November paper, November 2023. And there is a vectors over here also. I'll go, when I'll start with the November thing. Now, this is the old school vector that was part of P1 some years ago, but then they took this thing and sometimes they ask these things, sometimes they ask the intersection and skew and angle and exact ratio and all these things. So now over here, it says OC is 2K, OD is 2J, OA is 3I. It's a cuboid. It's not a cube because all the 3 lengths are not equal. And parallel to all these things, that's all given. Find the position vector of M. Does it say M is the midpoint? Yes. So this is 3I, this is 2J, and this is just 1K. So 3I, 2J, 1K, you can write it directly also, it's 1 mark. You can write in terms of IJK, you can write in terms of position, column vector. There is no limitation on that. The position vector of P is 1, 1, 2. Calculate angle PAM. Now, when they ask, this is very, very important. Let me take out a page and paste it over here. Hold for a second. When they ask for an angle with respect to a name, so if they ask for angle PAM, this is the angle point, and take 2 vectors diverging from a point. So AP and AM. So over here, 2 diverging vectors. 2 diverging vectors. Or if someone is interested, this is PAM. Someone can take 2 converging vectors. So PA and MA. So, or 2 converging vectors. Or take 2 converging vectors. So that is a must. You cannot just select it randomly. Calculate angle PAM, because if you select it randomly, your answer might come out to be wrong. Maybe they're asking for the acute angle and you are Might, no, I mean, unless they're asking for acute angle, and even if it's obtuse, it's coming out to be acute. In that sense, it will come out to be correct. But why take the risk? Why take the risk? So therefore, first of all, AP, that's AP, that's OP minus OA. And then AM, OM minus OA. I took two vectors divergent. I prefer to draw a diagram. AM dot AP, that is AM modulus, AP modulus cos theta, and we get this thing. And this angle is acute. Your choice, degree. Your choice, radian. I personally prefer degrees. How many marks? 4 marks. First part was 1 mark. Now it says, find the exact length of the perpendicular from P to the line passing through O and M. So equation of line OM, the easiest thing is take O to be the direction vector. Very easy. And lambda times M. What is M? OM is the direction vector, 3, 2, 1. So this is 0 plus 3 lambda, 0 plus 2 lambda, 0 plus lambda. This is P. So again, this is step 1. This it's written over here. Step 1, step 2, PQ, OQ minus OP. Step 3, dot product is 0. Lambda comes out to be half. Step 4, plug lambda is equals to this in PQ. And then the magnitude of PQ. So this answer is coming out to be in the exact form. So now let me choose one other question for vectors. Now, this is also nice. Let me choose both the complex number and the vectors from here. This is which year? This is October, November 2023, variant 32. Read the question, because there was a different kind of complex number question over here, something involving a lot of trigonometry. It says, on a sketch of an Argand diagram, shade the region whose points represent complex number Z satisfying the two inequalities. So there is a modulus lesser than or equal to something. That means it's a circle. And this next one is a real part of Z. So if I write Z as a complex number, real part is X, imaginary part is Y. So now focus on this. Inside the circle and left of the vertical line, X is equals to 3. So now over here, look at the shading. Let me grab my pen. It is inside the circle and left of this line, that is this region. So that was pretty basic. 3 mark, 4 mark, 4 mark. Find the greatest value of argument of Z for points on this locus. Naturally, when they are region or locus, they are asking with respect to shaded diagram, shaded region. Now, how many marks is this? 2 marks. Now this is less. This is less. So, I mean, the good thing is if someone gets it wrong, they won't miss out many marks on this. But of course, if you are getting the information from me, so you should get it right, inshallah. So now, first thing first, you need a lot of triangles. This is 4, this is 3, this is 5. I can calculate this angle theta. This is the radius. How much is that? That is 2. This is 5. I can even find beta. So the greatest value of argument of Z, that is for this half line touching this thing over here. That is the maximum. So you need theta, you need beta. This is a right angle triangle. This one is also right angle. Radius is perpendicular to tangent at the point of contact. Doesn't look like it. Of course, it's not a scale diagram. So I've drawn this right angle over here. Over here, the right angle is over here. Tangent theta is this thing. Theta is this. Over here, work in radians. So let me again focus over here. There are some chapters, some topics in which you have to work in radians. Differentiation, integration, differential equations, and numerical solution of equation, and complex and in complex when it involves trigonometry. So over here, I mean, they would accept in that thing also. So in complex, in trigonometry, it is preferable. So over here, this is preferred. Let me change the marker. So radians is preferred. But if they are asking about theta lying between pi inclusive, negative pi exclusive, then definitely radian. I think instead of preferred, let me write over here radians, radians all along. And one last thing, if it's a trick question, radians if asked for. If it says in the range, then we do it. So now over here, tangent of theta is 3/4. That is theta. Sine this is hypotenuse. This is opposite. Sine of beta is 2/5. That is this much. Maximum value is this much. Correct to 3 significant figures. So that was one question of complex number that I solved this thing also. We were focusing on vectors, but then this nice question came along. This is okay. Now, that is vectors. Read the question first. So now it says the equation of line L and M are given by such and such. So there is L, there is M. L in terms of lambda, M in terms of mu. C is a positive constant. It is given that the angle between L and M is 60 degrees. That is application of this thing, which is called scalar product. So let me just highlight this thing. Color. Okay. So now direction vector L into direction vector M, magnitude cos 60. Cos 60 is half. So first of all, you are getting -2 plus 4 plus 2c, which is 2 plus 2c. And this half from here, this 2 from here, goes on the other side and multiplies. This thing over here is this thing over here. And this thing over here, the green thing that's taken common, that is inside. So now square both sides. So what I've done is that I have taken this 2 common out. And then when I square, this 2 into 2 is 4, 4 square is 16. Basic thing, don't get it wrong. And this thing is this thing. Expand, middle term factorization, very high chance it will be factorized by middle term. C is positive 2, C is negative. What does it say? C is a positive constant. So C is a positive constant, therefore C comes out to be this. Show that the length of the perpendicular is this thing. We did many questions of this perpendicular, nothing special about it. So now let me look at this thing. Let's see if I can find some vector thing. This is basic. This one, yes, nice question. Complex and vectors. Let me focus on both. And then with all the energy left, I'd focus on our numerical solution. Solve the quadratic equation. Give your answer in this form. Now, first of all, it's a quadratic equation. The coefficients, look at the coefficient. The coefficient of w square, sometimes they write z, sometimes they write w. The coefficient of w square is 3 plus I. The coefficient of w is -2. The constant term is 3 minus I. There is an I involvement over here. So now keep in mind, when we have, let me write over here. When we have a complex roots of polynomials, whether it's quadratic, whether it's cubic, whether it's quartic, the roots occur in conjugate pairs. But this is possible only if the coefficients are real. Then it would be in the form a plus bi and a minus bi. That is the conjugate that we know of, conjugate pairs. Over here, when we take the square root, when we evaluate b squared minus 4ac, it is -36. So -36, let me highlight this. -36 goes on the inside. This is minus of -2 divided by 2, 3 plus I. Now you have to rationalize. So this is rationalization. When we rationalize, what are we getting? We are getting this thing W, that is 6/10 plus 8/10 I. And what is over here? That is the same thing. Hold for a second. Now, once with a plus sign, once with a minus sign. So there are two answers over here. This is 1 plus 3i over 3 plus I. This is 1 square root. 1 minus 3i over 3 plus. So over here, just focus on this. Got the idea? So one answer is 6 over 10 plus 8 over 10i. The other answer is 0 minus I. So it's just a coincidence that the negative, the i's balance out, and we are getting roots. They are not conjugates. That is the main thing. Definitely, they are not conjugates. Of course, they will be complex number, but it's just that they are not conjugates. That is the same thing. Now, let me look at this thing for a second. Okay. Now, last question of vectors, and then I'll move to numerical solution. The line L has this equation. The point A and B have position vectors such and such respectively. Find a unit vector. What is the concept of unit vector? It has a magnitude of 1 unit. Any vector divided by its magnitude is unit vector. So this is the vector. This is the magnitude. Divide. You can leave the constant on the outside. You can write in the IJK form. They did not mention anything. The line M passes through points A and B. Find a vector equation for M. OA, OB, AB. I choose OA to be my fixed point, AB to be my direction vector. So line AB is in terms of B. Line L is in terms of lambda. Determine whether L and M are parallel, intersecting, or skew. Nice question. Parallel, you can get it by observation. This is -1, 1, and 2. This is 5, -3, and 2. Lines are not parallel because direction vectors are not scalar multiple of one another. So you have to write this statement. So that is one thing, first of all. The next thing. Now, intersection and skew, unless and until you solve it, you cannot determine. So the x equals x, the blue equals blue, the green equals green. Solve it simultaneously. You get 11 over 2, and mu is -½ Plug in the third equation. Did not satisfy all three equations. Therefore, the lines are skewed. So now this thing is done. Now let me start with numerical solution. So let me just write over here for some people who have joined in late. So those people who were interested in integration, differentiation, and what else is there? Trigonometry, differential equations, and algebra and logs. So check out the video that was posted on Friday, I think 14th. So this is 14th or 16th. Hold for a second. Friday 16th. So check out the video that was posted on Friday 16th. That was session number 1. And right now, this is Sunday. This is 18th. Tomorrow, inshallah, is your paper, which you will ace. So complex vectors and numerical solution, popularly known as iteration. So that will be the next thing. So complex done, vectors done. Now the last thing is this thing. And then I'll be signing off for this particular academic year. So let me just get started with this. So numerical solution. Hold for a second. Now, sometimes in numerical solution, they don't even, sometimes there are years or sessions in which they forgot to ask numerical solution. So that is also a possibility. Now, I like this question. Why? Because they have drawn the graph of root x. Now, officially, this is not in the syllabus. There were 2 instances when they asked a question that was based on something which is not in the syllabus. So this is y is equals to x squared. So one-to-one function, the inverse would be root x. And that was one thing. And there was one other thing that was x cube and maybe x4. So let me just write it over here. Hold for a second. Let me write over here. And let me decrease the brightness. So hold for a second. Okay. Copy. They can ask you basic x4 and x5. Okay. So now, first of all, if I focus on this thing, that is y is equals to x squared. So that goes like this. That is y is equals to x squared. And y is equals to x power 4 will be a little bit more flatter. So let me get this thing. Something like this. It will be a little bit more flatter. So let me label it. Already taught in class. So therefore, this is y is equals to x squared. This is y is equals to x power 4. Similarly, if I am interested in y is equals to x cube, so like this, the basic x cube. So this is y is equals to x cube. And if I am interested in y is equals to x5, something like this. So this is y is equals to x power 5. So they have once asked x power 5. They have not yet asked x power 4. And this thing, you already saw it, that the square root of x for a particular domain. So hold for a second. So this is root x. And over here, like this. So this is y is equals to square root of x. All good? So, and then you draw e raised to power of x minus 3. So knowledge of sketches is assumed. Draw e raised to power of x. It has a y-intercept of 1. That will be shifted down 3 units. And the asymptote, you should also show the asymptote. I've shown it over here. That is, instead of y is equals to 0, this is y is equals to negative 3. And there is one point of intersection. Therefore, it's only one root. Show by calculation that this root lies between 1 and 2. So now, over here, the thing that you should remember is that for this calculation thing, transfer all terms on left-hand side and right-hand side should equal to 0. That is your function fx something. And then plug in both the values, f of something else. One will be positive, the other one will be negative. So that is by calculation. And yes, one other thing, that is, make sure your calculator is in the radian mode if there is something to do with trigonometry. So radian mode necessary if we are dealing with trigonometry, because sometimes they ask a question of circular measure. Sometimes they ask a question of differentiation. Sometimes it's integration. So they ask all these things. So now over here, fx is this thing, and you plug in 1, you get positive. You don't have to write the value. If you write it, that is good. You plug in 2, you get negative, since there is a change of sign. So make sure that you write the statement. So let me just highlight this thing, the color, and that's right away. Since there is a change of sign between f of 1 and f of 2, therefore root lies between 1 and 2. And then the proving thing, show that if a sequence of values given by the iterative formula converges, then it converges to the root of the equation in part A. So there are two options. Either take this thing, the in and out becomes the same, and just erase this and make ex, this thing, the subject that's given in the question. So this is like over here. This is iterative formula to equation. This is equation to iterative formula. Both are acceptable. Over here, from ex to ln, you have to take ln of both sides and then just write subscript 1x all alone on the left-hand side and rest of the thing over here. Use the iterative formula to calculate the root correct to 2 decimal places. Give the result of each iteration to 4 dp. So now, if they have not mentioned any starting value, since root lies between 1 and 2, the best value to start with is 1.5. You can start with any other value, but why take a risk? When we want to play safe, the best bet, the best thing is this thing. And now I think some, I think, so let me just write it over here. So what do you advise to do now? Just go over the basic stuff. Don't overstudy. Okay, someone also wrote, so this is what has been happening with me. So, sir, should I revise now? No. If someone has studied a lot, I already said it over there. Do not study, overstudy. Go through notes. If you feel that there is a need, then go through notes, otherwise not. Okay, so I have answered these things. And over here, what is the question? We have to do iteration. This is the starting value. Show the steps, show all the steps. And it's just you have to write ln and square root and +3. This value on the inside will keep on changing. This is changing and so on. Show all the steps, work to the level of accuracy that they have asked for. This is the only place where it is necessary. So where it is necessary that you work to level up. This is the only place. X1 is 1.5, you get this thing. X2 is this thing. Now there is a difference between the two. You plug in X3, you get this thing, 1.4352. Just focus on this, 4352. 4346. If I round it off, this is 1.44. If I round it off, this is 1.43. Therefore, I have to go one more step. So therefore, X4 is this thing. When two answers are exactly the same to the level of accuracy that they have asked for, you just stop your working over here. So that is one thing. Now in the other numerical solution, I'll just focus if there is any differentiation part or integration part. So I'll just focus on that. Over here, that is the graphical part. By sketching a suitable pair of graphs, show that the equation has one root in this interval. So cot x, yes, you should know the basic. Cot x, one cycle in 180 because tangent is the reciprocal of tangent. Tangent is like this. Tangent is between negative pi by 2, positive pi by 2. Cot one cycle between 0 and pi. We just need from 0 to pi by 2. 0 is not inclusive because that's an asymptote. So that is like this. Make sure you don't touch the y-axis. 2 minus cos x, that is cos x is like this. Negative cos x is like this. Negative cos x plus 2. So therefore, this is the y-intercept now. There is one point of intersection. Rest of the thing is the same as before. And over here, let me look at the numerical thing. There was no numerical in this one. Let me just look at this question. Yes, this is a nice one. Last question for today. So now the diagram shows part of the curve and the minimum point M, where x is equals to A, show that A satisfies this equation. And then the next part is about iteration and everything. So the first part is differentiation. So sometimes that's integration also. So u is x squared, u prime is 2x, v is cos 3x, v prime is this. Product rule, vu v prime plus vu prime. Equate it to 0. Plug in a, you can plug in later also. And you want a tangent. Do you need a tangent? Yes. So sine 3a, cos 3a, divide both sides by cos 3a. 3a squared tangent 3a is 2a. And take everything on one side because there is an a over here also. So I have to take this a, one a all alone common out. A is equals to 0. Of course, that is not the solution. So therefore, 3a tangent 3a, 3a tangent 3a minus 2 equals to 0. Tangent 3a is this, and a is 1/3 of tan inverse. So that is all about it from my side. And as usual, I can only say that just show all essential working, show all steps, be alert, read, skip any scary part, And of course, come back to it later. You will always have the time. Come back to it later. And naturally, take care of accuracy. Take care of accuracy. Take care of exact form. Shall people. Take care, everyone. Wish you the best of luck. Allah Hafiz, everyone.